ChatGPT. Seriously. I just forced Google's new Gemini 3 to build itself. I'm talking a complete full-stack clone created with zero manual coding using just one powerful power mode prompt. JS, Firebase, Vercel, the entire production stack crashed. But watch out! So I made the AI fix its own bugs. Want the exact prompt and source code? Let's build now. Let's start with the setup. Simple and clean. I'm jumping into VS Code and creating a dedicated folder for the project. Let's call it Clone. With the folder open, I'll toggle the integrated terminal. This is where we kick things off. I'm initializing the app with npx create next app at latest Gemini Clone. For the config, we're going with the modern standard. Yes to TypeScript, yes to Tailwind CSS, and yes to the app router. I'm keeping the import alias default and skipping the src directory to keep our root folder structure minimal.
A few minutes later.
And we skip the install wait time. Success. The boilerplate is ready. Now, instead of writing everything manually, I'm using Gemini 3 Pro. My prompt is specific. I want a Powerpack, a complete working clone, using Next.js, Firebase for the database, and Vercel for storage. Check out the thinking process here. It doesn't just guess, it defines the scope, plans the UI features, and structures the architecture before writing a single line. It generates the plan. An exact UI clone with a dark theme, a real backend using Firestore, and even simulated AI responses to start. It gives me a single file React component first, but I notice a small UI detail. I don't want a menu button near the name. So I ask it to remove that specific element. Once that's fixed, I ask for the most important part, provide the code in parts for Next.js 15. And this is the magic. It breaks the entire app down into a modular structure, prerequisites, Firebase configuration, API utilities, and components. This is the blueprint we are going to build. Finally, I ask to convert the entire code base into TypeScript for that extra layer of safety, though that's optional. We also make sure to include Vercel Blob for handling media storage, and we set up the env.local file to configure our API keys securely. With the blueprint ready, it's time to execute. I start by creating the folder structure Gemini suggested. First up is the types.ts file to define our data interfaces. This ensures our TypeScript setup stays strict and error-free. Next, I set up the lib folder. This is where the core logic lives. I establish the lib directory for backend logic. First, Firebase.ts connects us to the backend, initializing Firebase, Firestore, and Auth. This allows the app to manage user sessions and data. Next, I create Gemini.ts to house the AI's core logic. Here, I configure the Google Generative AI client and define the main function to handle both text prompts and uploaded base 6.4 images. Now, we move to the UI. I start by creating a dedicated components folder to organize our views. Inside, I build the sidebar, which handles the chat history list and the logic for navigating between different conversations. Then, I add the chat message component. This is responsible for the actual display of the conversation, rendering user inputs alongside the AI's responses, and ensuring the markdown text is formatted correctly. Here, I had to be careful. I initially created these as standard.ts files, but since they contain JSX markup, Next.js requires the .tsx extension. I quickly renamed them to ensure they render correctly as React components. For the main interface, I update page.tsx. This ties everything together, managing the chat state, triggering the API, and rendering the UI. To make this clone truly multimodal, I create a dedicated API route at app API upload route.ts. We are using the Vercel Blob SDK here to securely handle image uploads, allowing us to pass visual data to the AI. This is critical for activating Gemini's multimodal capabilities. I'm now installing the dependencies to power the application. First, I grab the @Vercel Blob package for storage. Next, I run a bulk install for the rest. Lucide React for the icons, React Markdown to format the AI's text output, and the Firebase SDK to handle authentication and database connections. This completes our project's required packages. Finally, we need to secure our application. I create a .env.local file in the root directory. This file acts as a private local vault for our sensitive credentials, keeping them safely out of our public code. I paste in the variable names for our Firebase config, Google AI Studio key, and Vercel Blob token. They are just empty placeholders for now. In the next step, we are going to fill them with the real secrets to finalize the entire setup process for the system properly and effectively right away. While reviewing the AI-generated code in Gemini.ts and the components, I spotted a syntax error. The import paths were pointing to @app types, which doesn't exist in our structure. I manually corrected these to point to @types, ensuring the module resolution finds our definitions. It needs a soul, a robust backend to handle data, identity, and intelligence. I shift from the code editor to the browser to set up this infrastructure. My first destination is the Firebase console. I initiate a fresh project, distinctively naming it Clone. As the wizard guides me, I reach the Google Analytics step. While analytics are crucial for commercial apps, they add configuration drag here. I explicitly toggle off Enable Google Analytics to keep the deployment streamlined before clicking Create. I wait as Google provisions the serverless resources. While the cloud initializes, I must verify exactly which environment variables I am hunting for, specifically keys and project IDs, so I don't miss any credentials while gathering data. Next, we need the brain of the operation. I head to Google AI Studio to access the Gemini API. Inside the dashboard, I generate a new key specifically scoped for this project. This alphanumeric string is vital. It is the authorized bridge allowing our local app to converse with Google's LLMs. I copy this key immediately. Back in Firebase, the Clone project is ready. I register a new web app named Gemini Clone. Firebase generates the Firebase config object containing the API key, auth domain, and project ID. I carefully extract these values to populate my environment file, linking localhost to the cloud. Now, I address identity. I navigate to authentication under the build menu and enable the Google sign-in provider. This ensures users can log in seamlessly with existing credentials, mirroring the true Gemini experience. Finally, persistence. I go to Firestore database and create a new instance. I select production mode to enforce secure access rules by default, rejecting test mode risks. After selecting the location, provisioning completes. Our backend is now fully live and ready. The first step is establishing robust version control. I head over to GitHub to initialize a fresh repository. I'm naming it Gemini-Clone to keep our naming convention consistent across platforms. I choose to keep it public for the sake of this open source demonstration, allowing others to learn from the code, though selecting private works just as well for proprietary projects. Once created, I grab the HTTPS remote URL to link our local workspace. Back in the Visual Studio Code terminal, we need to synchronize our local file system with the cloud. I initialize a new Git repository using git init, stage every single file in the directory with git add, and lock them in with a commit message. To ensure we align with modern development standards, I force rename the default branch to main using git branch and main before linking our remote origin. With a final git push u origin main, we send our codebase upstream. Now, our source code is safely stored, versioned, and ready for integration. Next, we switch gears to Vercel. As the creators of Next.js, this is unequivocally the optimal platform for hosting our application. I log into the dashboard, select Add New Project, and because I previously connected my GitHub account, Vercel instantly detects the new Gemini Clone repository we just pushed. Now pay very close attention because this is the single most critical step in the entire deployment workflow, configuring the environment variables. Remember that .env.local file we meticulously created earlier? By design, Git ignores that file to prevent your sensitive secrets from leaking into the public repository. That means Vercel, our hosting provider, has absolutely no knowledge of our API keys yet. We must manually bridge that gap to authorize our production environment. First, let's make sure everything is running smoothly on our machine. Head down to the integrated terminal in VS Code and type the command npm run dev. This will spin up our local development server. Once it initializes, you'll see a local host URL appear. Go ahead and click that to launch the application directly in your browser. Now that the local version is verified, let's check our cloud status. It looks like our Vercel deployment has finished building successfully. Let's switch over to the live project link on the Vercel dashboard. As you can see, the UI is fully loaded, responsive, and ready for action. However, we still need a back-end solution for handling file uploads. For that, we're going to set up Vercel Blob storage. Navigate to the Storage tab within your Vercel project, click the Create Database button, and select Blob from the available options. Hit Continue, assign a unique name to your store, pick the server region closest to you, and finally, click Create. And just like that, the storage is provisioned. To actually allow our project to communicate with this new storage, we are going to need the Vercel Blob key to configure our environment variables. I'll be covering that critical setup step in detail later in this video. For right now, let's run a quick functional test on the live site. It seems the site isn't responding to our requests just yet. It looks like we have a small configuration issue. But don't panic, we'll troubleshoot and resolve this completely in the next part. Before we dive into the code editors, there's one crucial administrative step. Open your Firebase console. We need to double check our authorized domains. We aren't doing the old copy-paste snippet routine. We want the AI to understand the entire architecture of our app. Head to your GitHub repository and copy the project link. Open the Gemini interface, specifically the advanced model with the import code capability, and paste your link. This is a massive leap forward. We aren't just asking a question. We are giving Gemini access to our directory structure, package.json dependencies, and component hierarchy. It analyzes the current state of the project, meaning when we ask for a fix, it knows exactly where the code belongs without us explaining the context. Let's test the current build. I'm firing up the local server, head to localhost, and immediate crash. The console is throwing a permission error. In the old days, you'd spend an hour on Stack Overflow. Today, we just grab the error log and paste it straight into our Gemini Pro model. Because Gemini already holds our repo context, it doesn't guess. It cross-references the error with our source code. The verdict: we didn't properly configure our Firebase storage and database rules. We are trying to write to the database, but security rules are blocking the request. Gemini has generated a corrected set of rules that essentially tells Firebase, allow read, write, but only if the user is authenticated. Copy this code, back to the Firebase console, go to the database tab, then rules. Delete the restrictive code, paste the new logic, and hit publish. The changes propagate instantly. Let's prove it. Refresh the local site to clear the state, send a message, and boom, it's responding. The permission error is gone. Now, a quick note on limitations. Image uploads won't work yet because we haven't integrated a file storage solution like Vercel Blob. Our database holds text, not heavy media. If you want a dedicated video on integrating Vercel Blob to build a system that analyzes PDFs, Excel sheets, and PowerPoints, drop a comment saying "analyze below" and I'll prioritize that. Speaking of storage, I want to mention a side project I've been working on called Aura IQ. It's designed to store memory, allowing you to save contexts and access them whenever you need essentially an external hard drive for your AI interactions. Check the link in the description. Back to the build. The app works, but the UX is raw. We need a proper entrance. Let's ask Gemini to add a user authentication page at the beginning. While it generates, let's check our model. Asking the chat, "What model are you?" confirms we are running on Google Trained Flash 2.5. It's incredibly fast for real-time interactions. If you ever need more reasoning power, you can swap this in your root.ts file. Gemini has provided a new authpage.tsx component and updated code for page.tsx. Create the file in your components folder and paste the code. This handles the UI for the login screen. The main page logic now checks login status. If logged out, show auth page. If logged in, show chat. However, I realized a flaw. Once logged in, we are stuck. We need a logout button and a way to clear clutter. Back to Gemini. Add a logout button inside a settings modal and also allow the user to delete specific chats. Gemini provides the update: a settings gear icon that pops out a logout menu and a trash can icon for chat sessions. This is the beauty of iterative AI development. You evolve the site continuously. I'm going to integrate this, but a quick piece of advice: do not fully rely on AI. If you blindly paste code, you will hit a wall. You must understand the logic, read the imports, and grasp the state management. That knowledge is what allows you to debug when the AI gets confused. Use AI as a tool, not a crutch. Okay, let's ship this. Run git add, git commit, and git push. Switch to the Vercel dashboard. It detects the commit, installs dependencies, builds the static pages, and we are live. Hit the live site, test the features, type a message, click the delete icon, chat is gone. Click the settings gear, hit logout, the new login page looks clean, log in with Google, and we are in. And we are kicked back to the login screen. The cycle is complete. We have a secure, authenticated, database-connected AI chat app with a polished UI. Thanks for watching.